Hello, everybody. Okay. So, welcome. This video is all about the power rule. Okay. So, at this point, you should have done a lot of calculations of this sort. Actually, calculating the derivative using the definition, which is this one. So we should be familiar with this by now, and how to find f of x plus h, and how to insert it into this expression, and how to the various ways of getting rid of the h in the denominator, and then plugging in 0 into the result to get the derivative. So this should be familiar. And just to summarize some of the results that I've gone over the following. If we started with x squared and ran it through this formula, this one here, then what we found was that its derivative is 2x. And I also did x cubed, and when we ran it through the same process, we found that its derivative was 3x squared. Okay. And the question really is there a pattern? Is there an easy pattern such that we can avoid doing this every time? Well, let's take a look. Let's look here. If we look at x squared, the exponent was 2. And look at what happened to it. It came down as a coefficient. And then look at the exponent here. The exponent here is 1. Okay? So, just by looking at this, it seems that the pattern is the exponent comes down and then is reduced by 1. Let's see if that same pattern is present here. Well, the exponent here is 3, and looky there. It came down. Then that exponent was reduced by 1. Okay? And again, you should have done several of these by now to see the pattern more than in just 2 places. This pattern is very general. Turns out, it doesn't matter what the exponent is. By running through this definition, if you have the following, let me change my color. If we have f of x, I'll just do this. Okay, I guess I'm at the bottom. Oh well. So let's just suppose f of x is x to any number. Now I'm putting an r up here. R designates any real number in the world. Okay? X to the power r. Okay, then the derivative, which we could write as dy dx. dy dx, or we can write it as f prime, or we can write it as df dx. These are all acceptable notations for the derivative. Is going to equal the following: rx to the r minus 1. Okay? This is the power rule. And you should have discovered it several times by now by running it through the definition of the derivative. From this point forward, we do not have to run these through the definition of the derivative. We can just make use of this pattern. The exponent comes down and is reduced by 1. Okay? So, let's do an example. A couple of examples. Let's say f of x is x to the 1,000. Well, then the derivative, just by using the power rule, is 1,000 x and then reduce by 1. 1,000 minus 1 is 999. There's the derivative. Okay. Let's do another. Let's do another. Okay. Whoop. So we have another function g. Let's say it's x to the 3/4. 3/4 is a real number, so there we go. Our power rule, we're going to take 3/4, bring it in front, and then we're going to subtract 1. 3/4 minus 1. So the hardest thing about this is doing 3/4 minus 1, right? 3/4 minus 1 is the same thing as 3/4 minus 4/4, which is 3 minus 4 over 4. And then 3 minus 4, of course, negative 1/4. So our final answer would be 3/4 x to the power negative 1/4. Okay? Works for any real number in the world. Let's come up a little bit. I didn't realize I had all this space up here. Let's do a couple more. H of x, all right? Let's say h of x is x to the power pi. Pi is a real number, so h prime, the derivative, which we can also write as dh dx. Bring the pi down, reduce the exponent by 1. Pi x to the pi minus 1. Okay. Hopefully you're starting to get the picture here. Let's say, let's see, I of x, right? Let's say it's x to the power e, right? Then the derivative will be e x to the e minus 1. Okay? J of x. Let's say j of x is the square root of x. This was a little tricky, but not really. We should be okay with the idea that square root is the same thing as the 1/2 power. So if we take the derivative, the 1/2 comes down, x to the, and then 1/2 minus 1, which is like 1/2 minus 2/2. 1/2 x to the negative 1/2. Okay? Using algebra, x to the negative 1/2 is like 1 over x to the positive 1/2. And this is like 1 over 2 square root x. Okay? So these are all the different ways to write that. K of x. Let's change the color for k of x, yeah? K of x. Let's say k of x is the 10th root of x to the 7th. Well, first thing, 10th root is like this, x to the 7th, and then 10th root is like 1/10. And here we have a power to a power, so we can just multiply the powers. If 7 over 1 times 1 over 10, that's like x to the, and then 7 times 1 is 7, 1 times 10 is 10, x to the 7/10. So if we do the derivative, which we can write this way, dk dx, the power is going to come down, 7 over 10, and then x, and then subtract 1, right? 7 over 10 minus, and then how do we write 1 in terms of tenths? 1 is 10/10, right? So we get 7/10 x to the, and then 7 minus 10. 7 minus 10 is negative 3. negative exponent, so we can bring him downstairs and make him positive, x to the 3/10. 7 over 10, and then 3/10 power, that's like the 10th root of x to the power 3. Okay. So I think this is honestly a pretty in-depth look at the power rule. We've basically covered every possible type of situation that you could encounter. So, that's that.